Now today we are starting with the new topic, that is solution of system of linear equations. Basic, I told you what was the system of linear equation, in what case it was homogeneous, in what case it is non-homogeneous, and then consistency. Consistency, I told you that a system is consistent if it has a unique solution. So this thing we have done, if it has solution, that will be unique or infinite, and if it does not have solution, we call that as an inconsistent. So here we will now find out in what case system is consistent, and if it is consistent, it has unique solution or infinite many solution. And second one, if it is inconsistent, then what should be the condition we should have. So I'll take a simple example now. These are the two equations and we have to solve it by matrix method. We should identify that the system is consistent or not. If it is consistent, then what should be the solution we should find out. So first thing, whenever this equation is given to you, we will create this equation in matrix form. What this matrix says, matrix will be having the elements 5, -7, 7 and -5. Okay, and then this will be multiplying with the variable x and y, and here this come out to be 2 and 3. This form is the representation of these this system of linear equation in matrix form, where we write this as A, this will be X, A will be this matrix, X will be this matrix, and that is coming equal to B. Whenever we want to solve this equation, we have to actually calculate X. X means this X and Y. If you calculate this matrix, we will say yes, the solution will be there. So our aim is to calculate this X. And if I want to calculate this X, I want to remove this A. And to remove this A, I should take A inverse on both sides. But before doing A inverse calculation on both sides or multiplying A inverse on both sides, before that we should check whether A inverse exists or not. So first thing what we do here, A inverse, whenever you want to calculate, you need determinant A. So first thing, I just go for determinant A. And determinant A, when I calculate, it will be 5 -7, 7 and -5. Now when you solve it, it will be -25 and plus of 49. And when you solve it, it will be 24. And when it is coming 24, this is not equal to 0. If it is not coming equal to 0, means I should say this matrix is a non-singular one, and I told in the previous lectures that whenever the matrix is non-singular, it is invertible. That means we will say this is not 0, system is consistent now. Why it is consistent? Because X I can get now, because A inverse is possible and I can get the inverse of it. So as the inverse I can calculate, that means X will be possible. And if it is possible, we will say system is consistent. So first thing, whenever system is consistent, determinant A should be C, not 0. And if it is determinant A not coming 0, then we say system is consistent and at the same time and has unique solution. Because denominator, when you take now if I take A inverse, denominator I'll just explain. A into A inverse into A into X is come out to be A inverse B. This is nothing but identity now. So I should say identity of X will be A inverse B, or I should say X will be A inverse B. A inverse will be what? It is adjoint of A by determinant A into B. And this value is known. Adjoint you can calculate. Every term come out to be a finite one because denominator is not 0. And as it is not coming not 0 form, that means we will say the unique solution will be there, or X and Y we can calculate easily. So keep in mind, first thing, determinant A we calculate. If that is not coming 0, we will say system is consistent and has unique solution. And that unique solution now we are calculating by taking A inverse on both sides. Then it will be X is A inverse B, and then it will be adjoint A by determinant A into P. Now my aim is to calculate adjoint A. What is your adjoint A? Find out now. Adjoint A will be the cofactor matrix transpose. If we take the cofactor of 5, will it come minus 5? When you take minus 7, the cofactor will be minus 7 because this is 1, 2 element. Then this element, the cofactor will be minus 7, and then this cofactor will be, this will be 2, 1. 2, 1, so it will come out to be plus 7 now. And then minus 5, this cofactor, it will be simply 5. This is your adjoint whole transposes there. And as you got the adjoint is this, now I can solve it easily. Then adjoint of A. What is adjoint A now? Take the transpose of it. Minus 5, 7, minus 7 and 5. Taken the transpose of it. B was 2 and 3. And X is what? That was X and Y. And what about determinant value? It was 1 by, what was the determinant? We have calculated that was 25, 24. So that was divided by 24. Now when you solve it, 1 by 24 remain as it is. This multiply with this now because this is having matrix 2 by 2. This will be 2 by 1. So new matrix will be with 2 or multiply with 1. So that means 2 by 1. That means 2 rows, 1 column. So it will be P11 and P21. These are the elements we will be having. Or I should say 1 by 24. First row, first column. Minus 10 plus of 21. And then 2, 1, that means this into this, that will be minus of 14 plus of 50. Now when you solve it, it will come out to be how much? 11. This will come out to be 1. And 1 by 24 remain as it is. So here, what should be X now? So I got it X comma Y is coming as 1 by 24. And this is 11 and 1. So what will be X now? X comes out to be 11 by 24 and Y is coming 1 by 24. This will be the answer we are going to have in the first question. So this is 2 by 2 equation, and in this case what I am finding, X and Y, they are coming unique. Unique value is X is 11 by 24, Y is 1 by 24. So here it means one thing is clear, that whenever you have a system, what that system we always write in form AX is equal to B. And in this case, first case which we got in this example, what that case says, determinant A is not 0. Determinant A, whenever you get not 0, we say system is consistent. And with unique solution. With unique solution. And how you calculate that unique solution? That already I told you. That will be X is equal to A inverse B. A inverse means adjoint A by determinant A into B will be your X. And then you can calculate X and Y, which will be there in X, and you can solve the question. So this will be the first thing we should keep in mind. Criteria for consistency. In that first criteria is, if determinant A not 0, system will be consistent with unique solution, and the way you calculate is this. One more example I'll take in next video, that will be of the same kind, in which determinant A will not come 0 and we will find out the solution of it. That will be a 3 by 3 matrix. In this we have taken 2 by 2 matrix. Okay, so we are going on next video now.